this video, we're going to study about organic chemistry. And organic chemistry is one of the most important branches of chemistry of all time. So, what is organic chemistry? It is the study of carbon compounds found in living things. So, in organic chemistry, we have homologous series. The first one is alkane. Alkane are saturated compounds. They have the general formula of CN H2N plus 2. What does this mean? It means if the N, the C, carbon, if the N is 2, then the hydrogen is going to be 2N, double the 2 plus 2. So it's going to be CN, that's going to be double 4 plus 2 is 6. If we have C3, H, double the 3 is 6 plus 2 is 8. If we have C4, the hydrogen is going to be 10. If we have C, the carbon 5, then the hydrogen is going to be 12. So this is what we mean by a homologous series. It is series of compounds which differ from the other by specific number and type of atom. So this has all these alkanes have carbon and hydrogen, all of them, and all of them are saturated. It means, what I mean by saturated, if we draw the structure of these compounds, if we have C3H8, now this compound, if we draw its structure, how is it going to be? It's going to be like this. The carbon is going to be saturated with hydrogen in this form. So this is how it is going to be. So if you look here, the carbon is bonded with hydrogen. Every carbon is bonded with hydrogen and carbon by a single bond. This is a single bond. And if you remember Lewis dot structure, this is carbon, and here it has 4 valence electrons. And so it needs how many electrons? It needs 4. So the hydrogen will bond with it, and every hydrogen is going to contribute with 1 electron. Here, look, this is so now the carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and then we make a line between these electrons to mean this is a bond, but every bond means 2 electrons. This is just something background, so we can work with this information in our mind. So this is how to draw the structure of alkanes. If you have C4H10, this is going to be drawn like 4 carbons, 1, 2, 3, 4. Now this 4 carbons will have 10 hydrogen around them, so these are going to be here 1, 2, 3 hydrogen around it. This will have 2 hydrogen. This will have 2 hydrogen. This, the last one, will have 3 hydrogen. This is what we mean by saturated, because they have single bond, and this is how we draw the structure. So in the exam or something, if you are asked to draw the structure of a compound, so like this, C6H14, then how we're going to draw? You start by drawing 6 carbon, 1, 2, 3, 4, 5, 6. Then you saturate it with these hydrogen around it. If you do not want to draw the hydrogens, okay, but as long as you draw these lines, which means bond, if you do not draw them or you forget some of them, then you'll not get a mark. So now we are going to look at how to name these compounds. To name the compound of alkanes, we give the number of carbon, then we end it with ane. We use this ane. We give the number, and the numbers of these carbon, we have, if you have 1 carbon, it's going to be meth. If you have 2, it's going to be eth. If you have 3, it is prob. 4, bot. 5, pent. and here you have 5, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. Now you use one of these, then you end it with ain. So if we have C, 3, H8. So 3, this is 1, 2, 3. 3 is prob. So prob is going to be probe, and we end it with ain, probane. So this compound, its name is probane. If we have like C, 7, H, we have 14, 15, 16. So this, how can we name it? 7 here is number 7 is hept. So it's going to be hept, and we end it with ain, heptane. If we have like 8, C, 8, H, 18, this is going to be 8. This is number 8, oct. So it's going to be octane. If you have C, H4, 1 is meth. So it's going to be methane. So this is how we name the alkanes. We give the number of carbon, then we end it with ane. So this is the prefix, and this we end the suffix. With the prefixes and suffixes, we use these. So easy to name this compound. You just need to memorize from 1 to 10. These numbers, you need to memorize them because we will use them in all the homologous series, which means we have another homologous series, alkens. Alkens here, if you look the difference, this we have alkane, and this is alken. This is the difference, only this letter. This is the difference between them. But the difference is much, much huger. These are saturated. These are not saturated. These have single bond. These have double bond. These have the general formula CN H2N plus 2. These have CN H2N only. So these are unreactive. These are reactive. So now this is the general formula of alkane, and how is that going to be? If we look here, this is how we draw the structure. The structure, alkenes have double bond. Okay, this is not saturated. This needs another one. This needs another one. So if you have like this, it's going to be saturated, but it needs 2 more hydrogen to be saturated. So they're not saturated. This is the general formula of alkenes. What does this mean? N. If the N is 2, then the H is going to be double only, 4. If you have C here 3, that's going to be 6. If you have C, let's say 5, this is going to be 10, and so on. This is how you know the difference. Is it alkane or alkene? This is how we know. If you have C2, H6. If you have C3, H8. If you have C5, H12. Now this is double this, so it is alkane. But this is double this plus 2. This is double this plus 2. This is double this plus 2, so this is alkane. And this is only double, so it is alkane, because sometimes you need to classify compounds you have like these. Then you need to classify them as alkane or alkene. Then this is how we know. Now, how to draw the structure of alkenes? They have double bond. This usually becomes in the second carbon. So this one, C3H6. This is how we draw it. 1, 2, 3. And the last one will have only 2 hydrogen, and the one before the last one will have only 1. to have it unsaturated. Then I'll give you example. C4H8. How we draw this compound is going to be 1, 2, 3. The last one's going to have double bond. The last one's going to have 2 hydrogen only. The one before the last one's going to have 1 hydrogen, and the rest will be just normally like the first group alkene. They will be saturated here. Okay, another example here, I'll give you C5H10. So how we draw this one? It is going to be 1, 2, 3, 4. The last one is going to have double bond. And now here we're going to write 1, 2 hydrogen. Here we're going to write only 1. And these will be saturated with hydrogen. You will draw hydrogen around them all. And this is how we draw the alkene. Some of the mistakes that students make, they make the hydrogen this instead of making it here, they make it here, they draw it here, and this is false. Why? Because look, if you have it like this one, see 1, 2, 3, 4, 5. Now the problem is every bond represents 2 electrons. So this is 1, 2 electrons. This is 1, 2, 1, 2, 3, 1, 2. Now if you draw it like this, it means this carbon is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. And there's no atom which can have this number of electrons. The maximum is 8. This is, we call it full octet. So this is not true because it has 10 instead of 8. And another mistake is this 1, 2, 3, 4, 5, 6. Only 6. And this is not full octet. It needs to have 8. So the best way to achieve this is to draw it like this. The last one before the last one should be saturated. So we will not draw it here. We will keep it here in its place. So this is how we draw the alkenes. Now we're going to look how to name alkenes. It's the same, just like the first group. We use these numbers, but in the first group we ended it with N, with this N. Now we're going to end it with N. So instead of N, N. If we have like this one C, ethane. If we have C2, H4, this is going to be 2 is 8, so it's going to be ethane. If you have C4H8, the 4 is 1, 2, 3, 4, both, so this is going to be butane. If we have like this one, 7C, 7H14 is going to be heptane. And this is how we name them. But notice that there is no methane. We don't have methane. Why? Because one atom of carbon doesn't make double bond. To have a double bond, at least you need to have 2 carbons. So one atom of carbon doesn't make this double bond. So in alkenes, there is no methane, because no compound with 1 atom of carbon can have double bond. So if it doesn't have a double bond, then it is not an alkene. This is one thing to bear in mind. Another thing is about the structural formula. This is here. If we write C, hydrogen here around it. Okay, hydrogen here, hydrogen around it. Now the molecular formula of this compound is C, 3H is going to be 8. But the condensed structure formula is we write the number of the carbon and how many hydrogen with it. So this carbon C1, one carbon, and how many hydrogen is bonding with it? 1, 2, 3, CH3. Then the second carbon, this one, the second carbon, C. How many hydrogen is there around it? 1, 2. So 2. Then the last carbon, this one, is going to be C. And the hydrogen around it has 1, 2, 3. So this is the condensed structural formula. If you are, it's the same like this, but this is molecular. This is condensed structure formula. If you have double bond, then it's going to be double. You'll have double bond there. But if you have like this one, see, 1, 2, 3. Let's erase this, then write it again. If we have this C, 3H. 6. This, if we draw, it's going to be 1, 2, 3 hydrogen here. Okay. Yeah, if you want to draw these hydrogen, you put them. If you don't, just make sure you don't forget to write the double bond. Now this, if we write the condensed structure formula, is going to be CH3. This, the first C has 3. This, the second C, H, only one. This, the last one, is C, H2. And this is how we draw the condensed structure formula. But usually we write double bond here, so we know it is a molecule with double bond. And that is it for this introduction of organic chemistry. In the second videos, we're going to look how to draw isomers and the properties of these groups, and we'll study much more. Until then, ciao.